Welcome to Get Your FRQ On. This question is from 2002. It's question 1, and it is calculator active. In the question stem, we're given two functions, f of x and g of x. And in part A of the question, we are asked to find the area bounded by the graph of f, the graph of g, the line x equals 1/2, and the line x equals 1. Now, in the question stem, we're given that f of x is actually just the function e to the x, and g of x is the function natural log of x. So if we understand anything about these graphs at all, we know that e of x, or e to the x, is greater than the natural log of x on this interval. If you don't know this, you can always graph these two functions on your graphing calculator to determine that e to the x is greater than natural log of x on this interval. So either way, you do have to understand which one is on top and which one is not so that we can set this up appropriately. All right, so now that we know e to the x is greater than natural log of x on this interval, the desired area can be found using a definite integral. So we just need the integral from 1/2 to 1 of e to the x minus the natural log dx, natural log of x dx. And again, this is a calculator active question. There's no point in trying to do this by hand. Just let your calculator do the work. The value of that integral is 1.223. In part B of the question, we are asked to find the volume when this region is revolved around the line y equals 4. All right, this is a calculator active question. So again, we're going to have our calculator do the heavy lifting here, but we do have to set up our integral correctly. So the volume of this solid, right, this is a volume by revolution, so this is going to be pi times the integral from 1/2 to 1 of our big outside radius, big R of x, which would now be 4 minus the natural log of x squared, minus our shorter inside radius squared, and our shorter inside radius would be 4 minus e to the x, square that. So I have this big integral, which again, don't try to do this by hand. Just don't. It's not going to be worth your time, even if you can do it correctly, which there's a good chance you wouldn't be able to. Let your calculator do this. The value of that integral is 23.609. Not a very difficult question if you let your calculator do the work and you understand how to set up the integral that you need. Now, just a reminder, when you use your calculator in a free response question, you do need to clearly communicate to the reader what it is you're asking your calculator to do for you. So one of the things that they would be expecting in an answer to this question would be, did the student actually write out the integral? Did you write v equals pi times this big integral before you gave an answer, or did they just write an answer? If all you have is 23.609, the reader has no idea what you wanted your calculator to do or how, in fact, you got this answer, and you would likely not earn any points. So when you have your calculator do something, just remember, you want to do as much of the calculus setup as you can, and then the calculator will do the actual calculation. In part C of this question, we are given a function h of x defined as f of x minus g of x, and we are asked to determine the minimum and maximum value of this function h on the interval from 1/2 to 1. So if we look at how h of x is defined, h of x is just the difference of f of x minus g of x, but f of x and g of x are both differentiable and continuous on this interval from 0.5 to 1, which means that our function h of x is also going to be differentiable and continuous on 0.5 to 1, which is good to know. All right, now because h of x is differentiable and continuous on the interval from 0.5 to 1, we can use the extreme value theorem. All right, h of x can have an extrema either at one of the endpoints, so x equals 1/2 or x equals 1, or perhaps somewhere in the interval from 1/2 to 1 where h prime of x is equal to 0. Okay, I should be able to find out what h of x is at 1/2 and 1 pretty easily. Again, it's a calculator question, so we can use our calculator to determine those values. But if the minimum or maximum occurs at some point in the middle, I don't know where that is yet, so I have to find that. So in order to locate any critical points here, I do have to find a formula for the derivative of h. If h of x is e to the x minus the natural log of x, then h prime of x equals 0 would imply that e to the x minus 1 over x equals 0, which I can figure that out using my calculator. The value of x that makes that true is 0.567. Okay, well now it's just a matter of checking. H of 0.5, if I use my calculator, I get 2.342. H of 0.567, if I use my calculator, is 2.330. And H of 1 is 2.718. All right, well, the question is asking for both the minimum and maximum value of H on this interval, so I actually have to list both, and I should label them. All right, so the minimum value of those three values is the 2.330, that's the smallest, and the maximum value of H on this interval would just be the biggest of those three values, which is 2.718.